Aloha! So, new topic today, the chain rule with trig functions. Let's go full screen, it's nicer. The chain rule with trigonometric functions. Catchy little picture on the side. Let's get to it. So the chain rule work with trig functions works pretty much the same way as it works with things that aren't trig functions, except with trig functions. So if I'm looking for the derivative of the sine of something, we're used to everything being so far the sine of x or the cosine of x or whatever it is. So if it's something other than that in the argument here, and this is the argument right there, the argument of the trig function, uh, we just treat it like we're doing the sine. So the derivative of sine is cosine. We don't change the argument. The argument does not change in this part. So if the derivative of sine of something is the cosine of something, and then we just multiply by that d something. That's the chain rule portion of things, the derivative of the thing in of the something part. Let's try an example because I don't know if all that something stuff makes sense. So if I'm looking for y primed equals. What's the derivative of sine? Cosine. Don't change the argument. And then we're going to multiply that by the derivative of the argument, 2x. And then to make it look nice, 2 cosine 2x. Okay, we don't want to leave the 2 dangling back here because then someone might want to change the argument, and we can't change the argument. Okay, 2 cosine 2x. So all of our trig functions, these look like the ones on the card now, they all have that little u primed at the end. Okay, the u primed is just the derivative of the argument. Derivative of the argument. And that trails along, well, you take it at the end, but generally speaking, when we do the rewrite portion, we pop that out into the front. Okay, we want that derivative of the argument to be the first piece in there. Okay, notice my argument does not change. I write that because argument does not change. Okay, and that's a good strategy for life. Don't change the argument. You know, don't be fighting for a later bedtime and then end up talking about whether you get to have chocolate chips or something like that. It doesn't make any sense. So don't change the argument. It doesn't make sense. Let's try a couple. Okay. So here, y primed. First of all, there it is. Thank you. Keep it. Don't show that. That again. First of all, derivative of cosine. Oh, this takes my pen away. Negative sine. Should we change the argument? No, we shouldn't change the argument. Okay. Then we're going to multiply by the derivative of the argument. Derivative of 3x squared plus 5x is 6x plus 5. And so make it look nice. Negative parentheses 6x plus 5 sine 3x squared plus 5x. I think I'll leave that tangent one for you to deal with, okay? So that's all we're going, okay? Derivative of cosine of something is the sine of something, negative sine of something, times the derivative of that something. Okay, this is my u primed, if you like. Okay, derivative of that. We bring it out in the front because we don't want to change the argument. I said that before. So do this tangent one, and we'll talk about that one tomorrow. Now, there's this thing called the repeated chain rule. Repeated chain rule. So what we end up doing is we want to, take I don't know what I'm saying, but we're going to deal with something that looks like this. We're going to rewrite, differentiate, simplify. So first we're going to rewrite. Now the sine cubed of something is like the sine of something cubed. So that's my rewrite. Okay? So I rewrite it that way. And the reason we usually put this cube there so that it doesn't get confused and change the argument. So PTA, in addition to being a delightful organization that fed us an excellent dinner before the open house, in this case stands for power, trig, argument. And when we're dealing with something like this, we end up doing 3 derivatives. Okay, first we do the derivative of the power. So I've got the derivative of something cubed. The derivative of something cubed is 3 something squared. Okay, so I've taken the derivative of the power. Now I've got to take the derivative of the trig part. Okay, so the trig part, what's the derivative of sine? Cosine. Cosine of the same thing. Don't be changing the argument. I may have mentioned that before. And then we do the derivative of the argument. The derivative of 6x squared plus 5 is 12x. Okay, so we'll work our way from the outside in. First to the power, then we deal with the trig, then we deal with the argument last. Okay, don't change the argument until you actually take its derivative. Then we simplify, and I guess I would probably just simplify this as 36x sine Sine squared 6x squared plus 5 cosine 6x squared plus 5. Call it done, okay? And this is, of course, because I've taken derivatives, I need to write that it's the derivative y primed equals, there we are. So, repeated chain rule, power, trig, argument, PTA. That's a site you can go to. That's the end. That's the end, really. That's all. Okay, so chain rule with trig, no real different from the other one. If we get into that repeated chain rule, and it's going to be a problem that looks like this, the sine, cosine, or whatever to some power, taking its derivative, and we have to do that three-step sort of chain rule. So it's like a chain rule within a chain rule within a chain rule. It just goes on forever and ever. Okay, so relatively quick, I think. Short amount of information. Hopefully it makes sense. If it doesn't, well, you know what you're supposed to do. You're supposed to ask some questions. Right about 6 minutes. Hope you learned something, and we'll see you tomorrow.